So for question one, we were asked to consider an American put option on a non-dividend paying stock when the stock price is $70. The strike price is $76. The risk-free rate is 4%, the volatility is 20%, and the time to maturity is 6 months. So using a binomial tree model with 5 steps through the DerivaGem output software, in part A, we were asked to find the value of an American put option at the stock price. To do this, we worked our way from right to left to find the value of the American put option at $7, which we found to be $7.07. Then for part B, we were asked to break down the option value into an intrinsic value component and a time value component. So to do this, first we found the intrinsic value of the American put option at the stock price of $70 by subtracting the value of the stock price from the value of the strike price. So $76 minus $70. So the intrinsic value component of the option is $6. Then we subtracted the intrinsic value component from the original option value to get the time value component. So $7.07 minus $6 equals $1.07. So the time value component of the option is $1.07. Then for part C, we were asked to determine the range of stock prices for which the time value component of the option would be 0. So using a trial and error approach with the DerivaGem output software, we determined that while keeping all other parameters constant, the time value component of the option will be 0 if the stock price is less than $64.70. At $64.70, the total value of the option will be $11.30, which we calculated using the DerivaGem output software, which is equal to its intrinsic value at that time, because $76 minus $64.70 is $11.30, thus implying that the time value component is 0. Finally, for part D, we were asked to discuss what the time value of 0 implies. So in general, a time value of 0 implies that the total value of the option will be equal to just its intrinsic value at that particular moment. For an American put option, this implies that the option will be exercised immediately.
Hello all, Parker Green here. I'm going to go over question 2 with you all. So at the stock price of $60, this would be a deep in the money call. And so I'll go over the stock price, like I said, is $60 and the exercise price is $0, making the risk-free rate 4%. And then the volatility would be 30%. The time is 1 year, and then the call option premium, basically the intrinsic value would be $60. Moving on to part B, just like the last question, we're at the stock price of $60. Exercise price is also $60. And then the risk-free rate's 4% with a volatility of 0%. And the time is also 1 year. This makes the call option premium worth $2.35. Going down to part C, as you guys all see here. Go over this with you. So it's similar to the last parts. So with the volatility at 0%, the option premium would technically only take into consideration with the risk-free rate of return of the exercise price of $2.16, along with the intrinsic value of $5. Third part of the question, like I said, the stock price is $60. Exercise price is also $65. So it's a little higher than last time. The risk-free rate is 4%. And the volatility on this one is 0%. And then the time is also 1 year. So given the volatility is 0%, the underlying asset can only fluctuate to a maximum of $62.45. This is taken into consideration of the risk-free rate. As it's stated, the call option with a strike price of $65 is essentially worthless at $0. Last part of the question, look, the stock price is $60. This isn't changing. Exercise price is also $60. The risk-free rate, 4%, staying pretty consistent. volatility is to infinity. And then the time is also 1 year, 12 months. So just 1 year. And then the call option premium would be worth $60. So given the volatility is infinity large, and the call option is at the money, the time value component of the option premium will be at $60. That's the stock price at the time. Infinitely high risk. So the insurance will be worth more than anything. Thanks all. And hope you guys enjoy the rest.
Question number 3. There's a common option strategy where an investor buys the asset, buys an out-of-the-money put option on the asset, and sells an out-of-the-money call option on the asset. So for part A on this question, we'll be comparing the exercise price of $75 with the exercise price of $45, taking into consideration the risk-free rate, because John, wants to have the strike price be the lowest at $45 and have the highest strike price at $75. So that's the range. So to start off with the $75 exercise price, taking into account the risk-free rate and volatility along with the time, the call option premium will be $4.35. And now analyzing the exercise price of $45, the put option premium will be $1.75. In order to cover the put option premium for the exercise price of $45, we'd have to long put that. And then for the exercise price of being $75, you would short call the $4.35 in order to cover that position as well too, which would give you an initial profit of $2.60. For part B, payoffs at maturity, if the stock price is lower than $45, you'll lose negative $15. And if it's higher than $75 or $75, it will be a $15 gain. So the payoff diagram would be this first position down here, which is the investor, so John buying the asset. The second position would be buying the out of the money option. And then the third position would be selling an out of the money call option, which would give you that $15 gain. For part C, the maximum profit and maximum loss. So John's considering that the strike price, the lowest strike price that he would have would be $45. The maximum net loss would be $12.40. And then considering that he would want a strike price at the high to be $75, the highest possible profit he can get would be $17.60. For part D, interest in the position, John or any other investor would be interested in a position if they believe that the stock price would be above $57.40 at the expiration in order to mitigate the downside risk to $12.40.
Before we had to go to NASDAQ.com and analyze real-world options for Microsoft stock. We chose a November 26 option since it had the nearest expiration date. And on November 19, which is when we did the exercise, the stock price of Microsoft was around $3.43. So we chose the option that was closest to the money, which is a $3.45 exercise price. And this option had a call premium of $1.95 and a put premium of $3.78. And using the options discussed in the prior slide, the cost of a straddle will be $5.73 since you are going to be long one call option and long one put option. And in order for you to break even on your straddle, the stock price must be either greater than $350.73 or $339.27 upon expiration, which equates to a plus 2.2% up movement or a minus 1.1% down movement from the current stock price. And then moving on to part D, we selected a December 23rd option. with the 345 strike price since it was approximately 1 month out. And this option had a call premium of 709 and a put premium of 920. And then using the December 23rd option discussed in the prior slide, the cost of a straddle would be 16.29 since once again, you're going to be long one call option and then long one put option. And in order for you to break even on this straddle, the stock price must be either greater than 361.29 or 328.71 upon expiration, which also equates to a plus 5.3% up movement or a minus 4.2% down movement. And then if I were to take a long position on a straddle in part A and the short position on the straddle in part D, I will essentially be anticipating that the price of Microsoft stock will be either greater than 350.73 or less than 339.27 on the expiration of the November 26 option, which perhaps is related to some event that drives near-term volatility. However, at the same time, I will also be betting that Microsoft stock will remain between 328.71 and 361.29 on the expiration of the December 23rd option.